Now, we are going to talk about two things today, addition rule and complements. The first thing, we have a definition. Mutually exclusive, sometimes this is called disjoint. These are events with no common outcomes. Okay, if I roll a dice, getting a 2 and getting a 5 would be mutually exclusive events. Because if I roll one die, is there any possible way I could get both a 2 and a 5 at once? No, those are mutually exclusive. There is no overlap. There is no way for both to happen at the same time.
But how would you roll the same dice?
Alright, so if our events are disjoint or mutually exclusive, then if I want the probability of those events, E or F happening, all you have to do is add their individual probabilities.
So I'd get like a 2 or a 5 2 out of 6 times. Or 30
Right.
times.
So for my dice example, I'm going to roll the die. The probability of a 2 or a 5. All we have to do is add the probability of getting a 2 plus the probability of getting a 5. Probability of a 2, there are 6 sides on a die, so that's 1 out of 6 plus 1 out of 6. So you get 2/6 or 1/3. So if they are mutually exclusive and there is no overlap, I'm not going to roll my die and get both of them, then you can just add your individual probabilities together.
Why would we do this? Like, what's the reason that we'd ever like need?
Because a lot of times when we're calculating probability, I'm not just asking for the probability of one thing happening. I want to know this or this happens.
Roll a 2 or a 5.
Well, if your total probability is P times E plus, or probability of U plus probability of F.
Now, this is only if you have mutually exclusive or disjoint. So let's look at an example now. The probability model, we talked about our probability models yesterday, shows the distribution of the number of rooms and housing units in the United States. That is kind of tiny. Can you guys even read that? Okay. So, part A, verify it's a probability model. If it's a probability model, every probability has to be between 0 and 1, which it is. And what was the second requirement? Alright, add them up and make sure it equals 1. And we do get 1, don't we? So that tells me it is the probability model. B, what is the probability a randomly selected housing unit has 2 or 3 rooms? Would that be mutually exclusive? Can you have both 2 rooms and 3 rooms in the unit at the same time? No. If you count the number of rooms, it's one or the other. So that's mutually exclusive. So what we have to do is add the probability that you have 2 plus the probability that you have 3. So the probability of having 2 is 0.032. Probability of having 3 is 0.093.
Just add them.
So 1/8 or 0.125 sheets. Part C, what is the probability a randomly selected housing unit has 1 or 2 or 3 rooms? What would you do?
Just add them all.
So you could add them all individually. You could use the answer that we got on the previous one as well. And we get 0.135. Okay, but this rule only works if the events are mutually exclusive, if they can't both happen. But if I wanted to find something like the probability that a student in my class has blue eyes or brown hair, we know that it is possible, if I just counted people with blue eyes and I counted the people with brown hair, could I have double counted somebody? Definitely. So we can't just add those probabilities together. In general, if it is not mutually exclusive, we have the general addition rule. What that means is you will add the individual probabilities and subtract the probability that they both happen. You're going to subtract off those people that you double counted.
So if you say there was like 5 people had, like there was 5 people total, one of those had both, then you just subtract them.
For each or total? The total.
If you have mutually exclusive events, you could use this formula too. If they're mutually exclusive, what would be the probability of both of them happening? 0, because it's impossible for both of them to happen, so it would just be subtracting 0 off the end, which doesn't change it.
You don't need to memorize.
Right, you really, this is the more important rule to remember, because you can always think just subtract 0 if they're mutually exclusive. And again, you guys will still have your formula sheets.
Is this on there?
And if you're looking on chapter 5, it has these things on there. Okay. Ready to look at an example? So a pair of dice are thrown. Okay, and I just illustrated every possible outcome up here. Let E be the event the first die is a 2, and F be the sum of the dice is less than or equal to 5. Find the probability of E or F. So, that's the probability of E plus the probability of F minus the probability of E and F happening. The probability of E, the first dice being a 2. How many times is the first dice a 2 in this? 5, 6. Out of how many total times, Stu? How many combinations are up here? 36. Okay, F. The sum is less than or equal to 5. This is less than. Could you do the 5 plus 1 though? Okay, I couldn't do 4 plus 2, but I could do the 2 plus 3, 2 plus 2, and 2 and 1. 3 and 1, 3 and 2.
Wait, I'm confused.
I'm counting all of them that are less than or equal to 5.
All of them.
I thought it had to be like 2. Like the first dice had to be 2.
Oh, no, right now I'm counting just F, which is just when I add the dice, they're less than 5.
F doesn't have anything to do with 2, it's just 5.
So how many events did they add up to 5 or less? Hmm? 10 out of 36. E and F. I want to know how many did I double count? How many of these had the first dice being a 2 and the sum was less than or equal to 5? These 3. I have double counted those, so I have to subtract off 3 out of 36. So if you do that, you get 13 out of 36. Or if you gave me a decimal, it's 0.3611. You guys know what a deck of cards looks like, right? So suppose a single card is selected from a standard deck. Compute the probability of drawing a king or drawing a diamond. So I want the probability of a king or a diamond. Write out your formula. We're going to continue calculating probabilities in the next few days. Strongly suggest get in the habit of writing your formula as you begin. That will help you tremendously as we keep adding more pieces to the puzzle. It will also help me if I'm grading your work and something went wrong. It'll help me see where you went wrong. So get in this habit. So that is the probability of a king plus the probability of a diamond minus the probability of both the king and diamond. So in a deck of cards, how many cards are in a deck?
2.
How many of those are kings?
4.
Okay. Out of the 52 cards, how many are diamonds?
16. No, 13.
13, because there's 4
Yeah.
suits, so 52 divided by 4 is 13. Okay. How many of those cards are kings and diamonds? So 1, the king of diamonds. We've counted it twice. So I get 16 out of 52. You could write it as a fraction in lowest terms, or just give me the decimal 0.3077. So far, so good. Let's do another example. Okay, so I have put this table about marital status up here. So the first thing I want to do is determine the probability that a resident is male. What am I going to have to do first? We're going to need our totals here. Let's add them all up. So if I add my males,
Love how there's
they're in millions.
Oh,
You would rather I give you 11.2 than,
yeah, I know.
okay, so my males add up to 122.5, add up the females. Get 128.8. I also need a grand total, so if I add those, altogether, this table's talking about 251.3 million. So the probability the resident is a male, what would you do? The males out of the total. So 0.4875. Okay. The probability a resident is widowed. Okay. A couple different ways of doing this. You could, probably the easiest way is just to add up all the widowed, which would be divide that by our total. Everybody know how we're getting these? Part C, the probability that a resident is widowed or divorced. Let's write it out. So I want the probability that they're widowed plus the probability they are divorced minus the probability that they are widowed and divorced. Okay. Well, I'm assuming, I guess we are probably talking about multiple marriages,
then you get
but
a divorce and a widow.
this
but-
table isn't accounting for that. So the probability that somebody was widowed, if we look at this table, that was 14.3 over 251.3. The probability that they are divorced would be 25. Now, in this table, does it give an option where you can be both? No. So it is most likely accounting for first marriages only in this table. So what would I call these events if there's no overlap?
Mutually exclusive.
Those are mutually exclusive. So you just have to add them together. So 0.1580. The probability the resident is a male or widowed. So that's probability of male plus the probability widowed minus the probability of being both. The probability of being male was 122.5 over 251.3. The probability of being widowed, and you could use the decimals we already found. I'm just going back to the fractions because of rounding error. That way I don't have to worry about that issue. Okay, the probability of both. So being a male that is widowed,
Wouldn't you just do like minus 3.1
over
the original?
Mhm. and we get 0.5320. So the amount of work I'm showing up here, that's what I expect of you guys. I don't want you just writing down a final answer. I need to know what you're putting in your calculator and how you're getting there. So you should be writing those little pieces out for me. All right, any questions about the ors, the adding? The last thing I want to mention today is what are called complements. So if you have a sample space S and E is a particular event, the complement, different books use different notations. This book uses an E with an exponent of C. A lot of times you will see an E with a bar over it as well. That means the complement, it means everything in the space that is not already in E. Okay, so if I did my students in this classroom with blue eyes, the complement would be everybody in this student or in this classroom who doesn't have blue eyes. They are complete opposites of one another. So if you add both together, you should always get a probability of 1. Okay, according to the American Veterinary Medical Association, 31.6 of American households own a dog. What is the probability that a randomly selected household does not own a dog? So the probability that they do not have a dog, would that be the complement of having a dog? Because you either have a dog or you don't. There's no other option. So to find that, we just have to do 1 minus the probability that you do have a dog, because they are complements. So 1 minus the probability of having a dog. How would I put that in my problem? Point 3. And so we get 0.684. So the probability that you don't own a dog is 0.684.
Wait, what did you do? Wait, what's the 1?
Because it's complement.
That's like the 100%. So those two have to add up to
Oh.
Now that would only work if I'd said the probability that the person, the household, does not own a pet. Would I be able to do this? No, because dog and does not own a pet, that doesn't fill every possibility, right? You could have a pet other than a dog.
You could
So,
have a lizard.
yes, you could have a
There's
lizard.
a possum in my garage and his name's Jeffrey. So, he's my
Okay.
pet.
I don't think you're supposed to have like pet wild critters like that.
Okay,
The
so
dog do.
last example. The data travel time to work for residents of Hartford County, Connecticut. What is the probability that a randomly selected resident has a travel time of 90 or more minutes? So,
So the 4,805
Yeah, divided by everything.
yeah, we're gonna have to find everything first, aren't we?
That's really gross.
Oh, we have a calculator we can add. Alright, add all these up. I got a grand total of 39,000, no, sorry, I put my calculator in the wrong spot. 393,186. So that's my total. Anybody get the same thing as me? Okay, I'm gonna assume I'm right then.
Yeah, because I'm just illiterate.
Alright, and I wanted 90 or more minutes, so I have to take the 90 or more and divide them. And then I get 0.0124. Okay, so part B. Compute the probability that a randomly selected resident will have a commute time less than 90 minutes. Okay, we just found the probability that they had more. So less than 90, I could go through and add up the less than 5, the 5 to 9, 10 to 14, 15 to 19, and add up all those. Or I could realize if this is 90 or more, wouldn't less than 90 be the complement of it? You have to be one or the other. You're either less than 90 or you would be 90 or more. I just found the probability that it's 90 or more, so the complement would just be 1 minus that.
Wow, look at us. So freaking smart.
And so that